Hello, everyone. Is that all loud and clear? Can you all hear me properly? Hello, everyone. How's your day? So if you can hear me loudly and properly, you can just type a 1 in the comments to let me know, all right? Okay, that's nice. Okay, so it's 6:56 now, and I would be starting at 7 p.m. sharp, all right? So I will try to cover everything in this paper as I can. There are 25 questions altogether. So I hope that in the 1 hour time, I would be able to cover all the questions. Okay, so thank you everyone for your patience. We will be starting at 7 p.m. sharp, okay? Welcome everyone, welcome. Yep, so just wait for another 3 minutes. If you have already done the paper, you can just put it aside you, together with your answers ready, and we will be going through the questions together, okay? So still 2 minutes to go. Okay. So let's see how many of you are here ready. Nice. So thank you all for coming. We will just be waiting for another 2 minutes and actually 1 minute, and we will be getting started with the paper. All right. So I'm hoping that I can cover everything, but based on the principle that you have learned about the prior knowledge or the basic knowledge you need before. So if there's anything that you haven't learned about, of course, I won't be able to cover all the details in these questions. So what I can do is to try to explain every single question as to how to do that, and that's going to be as in like how you can try to solve every single one of them with enough prior knowledge, okay? So it's about time, and let's get started. So hello everyone, this is Tiger from Think Academy, and today we're just going to look at this 2023 P3 TASMO sample paper. All right, so there are 25 questions altogether. The first 10 questions are going to be multiple choices, and next 10 fill in the blanks, and the last 10 are going to be more comprehensive ones. Okay, so let's take a look at the first question right here. So now we have a number pattern, and you can see that between numbers, you don't really see a pattern between each of these numbers, right? It's like +4, no change, -1, so on, so on. So that does not really have a clear pattern. However, if you're taking a look at skipping numbers, you can see that 4, 8, 12, and 16 are going up by 4 every time, right? As for 8, 7, 6, and 5, that belongs to another group, which goes down by 1 every time, right? So you can see that that's actually 2 patterns going alternatively. And the next number should be from the blue one, should be from the blue pattern. So it's going to be +4, which goes to 20, which is C as the answer. All right, so that's the first question. I believe everyone should be fine with that, as long as you can observe the correct patterns. And then let's move on to the second question right here. So for the second question, it says that in a given month, there are more Tuesdays than Wednesdays and more Mondays than Sundays. So what day of the week is the third of that month? Now we need to realize one thing, okay? Which is in any month, the minimum number of days is going to be 28, right? Say if it is February. And even if there's 28 days in a single month, that would still be 4 complete weeks, which means that every day in a week is going to happen at least 4 times in a month, right? So if there are more Tuesdays than Wednesdays, it means that there are 5 Tuesdays and 4 Wednesdays. If there are more Mondays than Sundays, it means that there are 5 Mondays and 4 Sundays. Is that making sense, everybody? So now, we know that for Sunday and Wednesday, there's 4 of them. But for Monday and Tuesday, there are 5 of them, which means that there are 2 days on top of 4 weeks for this month. And the 2 extra days are going to be Monday and Tuesday. So this month is going to be looking like Monday, Tuesday, and then Wednesday, Thursday, Friday, Saturday, Sunday, repeating 4 times. And that's going to be 28 days with an extra Monday and an extra Tuesday. So that's how you can get 5 of Mondays and Tuesdays, 4 Wednesdays, and 4 Sundays. Is that right? So that's the reason why the third day of the week, the third of that month is going to be a Wednesday. Is that okay? So this month must be starting from Monday and Tuesday, ending with Monday and Tuesday. All good? That's how we can figure out the second question, all right? So now we are at the third question. For the third question, it says each of the box is called a cuboid, and each of them is made of 6 cubes. All 3 figures are the same size cuboid because you can see that it's literally just rotating a cuboid which is 1 by 2 by 3 for the length, width, and height, right? So rotating it does not make it different. Now, how many cuboids of different sizes can be formed using exactly 20 identical cubes? In other words, how many different vector triplets can I split 20 into? That's the question. So first of all, think about it. If I have just 1 layer for these cuboids, I would be able to do a height of 1 times a length and width of 1 by 20, a height of 1 times a length and width by 2 by 10, a height of 1 with lengths and width 4 by 5. So these are the 3 possibilities that we can have. And as for the height of 2, of course, we can do 1 by 10 for the other 2 dimensions. That's multiplying to 20. However, that would be repeating with the second one, right? 1, 2, 10. So I'm not counting that as a different cuboid. Instead, I'm just doing 2 by 2 by 5 as the remaining option. So you can see that there's no other possibilities I can form with 20 identical cubes. And that's the reason why these are the 4 different dimensions you can have using 20 cubes. So the answer is going to be 4, okay? And that's for question 3. All right. So question 4. Now, 6 girls share an apartment with 2 bathrooms, which they use every morning beginning at 7 o'clock. They use the bathrooms one at a time and sit down to eat breakfast together as soon as the last girl is finished. So they waited until everyone is done using the bathroom and they will start eating breakfast. Now, the 6 girls spent 9, 11, 13, 18, 22, and 23 minutes in the bathroom, respectively. If they are well organized, what is the earliest they can have breakfast together? So now, there are 2 bathrooms, right? And all of the girls will spend 9 adding 11, adding 13, adding 18, adding 22, adding 23, which is going to be 96 minutes altogether. Yeah? So theoretically speaking, the best possible time for them to finish is going to be 48 minutes for each bathroom, and such that both of them finishes at the same time, right? Because that's 96 divided by 2, of course. But you can realize that among these 6 numbers, none of the 3 are going to add up to 48, which means that the theoretical best is impossible. Is that making sense? So then we want to look at what's the alternative for that. So the alternative is when I have 9 and 11, and when I have 11 and 13 and 23 added together. That's going to be 47. And if I have 9, 18, and 22 adding together, that's going to be 49. So it means that for one of the bathrooms, it takes 49 minutes for the girls to finish. And for the other, it only takes 47 minutes. But since that they are waiting for the last girl to finish, that's the reason why they can only start 49 minutes after 7. Is that okay? Longest that start first, and then you can take the short one and the short one finish. Yeah. You can just try to think about the total. So the best way is to have both bathrooms having the same time, right? But if it is impossible to allocate it, then what we can do is then take the next possibility, which is like 47, 49, and that is feasible. So that is the reason why it can only be 49. Okay? So that's for question 4. And now, everyone, let's take a look at question 5, which is a logical deduction problem. So we have Amy, Bob, and Chris each belong to one of the 2 tribes, either truth tellers who always tell the truth and liars, who are people who always lie. Now, Amy and Bob made the following statements. Amy says that all of us are liars. We know that this statement cannot be true Because if it is true, then it means that Amy herself is also a liar, right? Which contradicts with the fact that the statement is true. It means that the statement is definitely false, which means Amy is going to be a liar. Is that right? And as for Bob, exactly one of us is the truth teller. So if Bob is telling the truth, then it means that Bob is the only truth teller and Chris is also going to be a liar, right? That's the first possibility. And now let's think about the second possibility. Say Bob is a liar as well, which means not exactly one of us is the truth teller, right? However, since not all of them are liars, Chris cannot be a liar as well, right? If Bob is a liar, saying exactly one of us is a truth teller, then it means that all of them has to be liars, which means Amy is actually correct. So either way, that's contradicting to the statement, which means that Bob has to be a truth teller. And if you still remember the previous conclusion, because exactly one is the truth teller, is true. So Bob is the only truth teller. And Chris is also going to be a liar. So among all these options, you can see that D is the one that satisfies this. Yes, that's right. Use their words and try to test if their decisions are correct or not. Yeah, exactly. Logical deduction problem, right? So the answer is D, which fits what we have as the conclusions. Is that okay? So that's for question 5. Now for question 6, it's a really easy question if you know the divisibility of 9. So we are trying to replace x by a digit such that the 5-digit number xx4xx is divisible by 9. We know that for the divisibility of 9, it means that all of the digits are going to add up to a multiple of 9, right? So it means that if I'm counting x 4 times, that is 4 times of x, that adding 4 is a multiple of 9. Which also means that if you're extracting the common multiplier 4, 4 multiplying x adding 1 is a multiple of 9. Which also means that x adding 1 itself needs to be a multiple of 9. Is that right? Because 4 is not a multiple of 9. So for 4 times of that to be a multiple of 9, x adding 1 itself has to be a multiple of 9. So the only number within the options that adding 1 is a multiple of 9 is going to be 8. So the answer is going to be 8 for this question. Is that right? So that's what we have for question 6. All good? Okay, and for question number 7. So first of all, it is defining this operation called the factorial, which means you're starting from that number and you're actually just multiplying 1 all the way for all consecutive numbers up to the number written there, which is n. For example, if you have 2 factorial, that is 1 times 2. So 1 multiplying all the way up to 2. If you have 7 factorial, it is 1, 2, 3, 4, 5, 6, up to 7, all multiplying together. Is that right? So that is how we define this operation, a factorial. It tells us that the number of hours in September is written as n factorial. We know that in September, there are 30 days. And in each day, there are 24 hours. So 30 times 24 is the number of hours in September. We also know that 30 can be written as 6 times 5. 24 is equal to 4 times 3 times 2 times 1. So altogether, that's going to be 6, 5, 4, 3, 2, 1, all multiplied together. And that is going to be the same as 6 factorial, which means This n that we're trying to find is going to be 6, right there. Okay, so that is for question number 7. All good? All right. So, question number 8. It tells us that a class of students goes kayaking. If they add an extra kayak, each kayak can seat exactly 6 people, right? If they remove one kayak, each kayak must seat exactly 9 people. So how many students are there in this class? This is an excess sufficient problem, all right? Basically, like excess and shortage problem, sorry. What we can see here is that, say, there are a number of kayaks. I don't know how many, all right? But there are a number of kayaks originally. If they add an extra kayak, then each kayak is going to seat 6 people, right? If they remove one kayak, each kayak can seat 9 people. Of course, by removing one kayak, yeah? So now, what it means is that, say, the difference between the two cases, you can see that, imagine if they have the same number of kayak, then it means that there will be 6 fewer people right there, yeah? There will be 9 more people right there. The difference is going to be 15 people, right? Between them. So imagine they have the same number of kayaks, which means now there are the same number of kayaks in both cases. The second case will have 15 more people than the first case, because the first case has 6 people less and the second case will have 9 people more, right? So now, the result of 15 people is resulted by every kayak having 3 more people, right? So that's the reason why the original number of kayaks is going to be 15 divided by 9 take away 6, which is 3. And the 15 actually comes from 9 adding 6. So that is how we can understand the excess and shortage problems. We just add the excess and shortage and then divide the two cases difference, all right? So that's like the total difference divided by the by case difference to find out that there are 5 kayaks originally. So it means that if there's one extra kayak, there's going to be 6 kayaks, each with 6 students. Or if there is one fewer kayak, there's going to be 4 kayaks with 9 students each. So the number of students is either 5 adding 1 times 6, which is 36, or 5 take away 1 times 9, that is 36. Either way, okay? So B is going to be the answer. That's for question 8. So now we are at question 9. It says that teacher Yuxin asks each student in her class to draw a rectangle with integral side lengths, which means side lengths are integers, and a perimeter of 50 units. So now all of her students calculate the area of the rectangle they draw and what is the difference between the largest and the smallest possible areas. So now we know that if the perimeter is 50, it means that the length adding the width multiplying 2 is going to be 50, right? Which means the length adding the width of the rectangle always needs to be 25. Is that making sense to everyone? So for a fixed sum, the smaller the difference between the two numbers, the bigger the product, right? So it means that the largest area is going to be the smallest difference between them, which is 1, when I have the length as 13, the width as 12. So 13 multiplying 12. That's going to go to 156. And the smallest area is going to go to the biggest difference between the length and the width. So the length can be 24 and the width 1, which is going to be 24 as the smallest possible area. So now the difference between them is going to be 132. Is that okay? So that's how we can get the answer for question 9. All right. So this is going to be the last one of the multiple choices questions, question 10. So for question 10, the whole numbers from 1 to 2016 inclusive are written on the blackboard. Maurice is underlining all the multiples of 2 in red, all the multiples of 3 in blue, and all the multiples of 4 in green. So how many number does Maurice underline exactly twice? So if you're trying to think about it as a little bit of a Venn diagram, it means that, say, this is the multiples of 2, 3, and 4. The numbers that Maurice underlined exactly twice is going to be the numbers in these 3 sections, right? And as for these 3 sections, each of them is going to be the overlap of the 2 circles, removing the overlap of the 3 circles, right? So how we can calculate it is try to see how many numbers are in the overlap of each of these 2 circles, and then removing the overlap of all 3 circles 3 times. Is that okay? In order to calculate the overlap of 2 circles, basically that goes to the lowest common multiple. We know that the lowest common multiple of 2 and 3 is going to be 6, right? The lowest common multiple of 2 and 4 is going to be 4. And the lowest common multiple of 3 and 4 is going to be 12. So now I am just trying to see what is in the overlapping part of them. So let's say that is going to be O, all right? The overlapping part of 2 and 3, which means that the marks with 2 and 3 together is going to be 2016 divided by 6. That goes to 336. The overlapping part of 2 and 4, which means numbers with 2 and 4 marked on both of them, is going to be 216 divided by 4. That is 504. And finally, the overlapping part of 3 and 4, that's going to be 2016 divided by 12, which is 168. All right. So now we also need to know the overlapping part of all 2, 3, and 4, which we also know that the lowest common multiple of 2, 3, and 4 is just the same as the lowest common multiple of 3 and 4, which is 12. So the overlapping part of 2, 3, and 4 has 168 168 numbers. So now the total number of numbers that Maurice has underlined exactly twice is going to be 336 adding 504 adding 168 number 10. We are good? Okay, now, so we are then moving on to filling in the blanks. So what we have here is that we are trying to count the number of triangles in this figure. So we can start counting by what kind of shapes they are looking like. First of all, we can try to count the triangles which are formed by only one triangle. All right. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which are formed by one triangle only, right? And now, counting for two triangles. So you can see that for each side, you will be able to form two of these triangles, say 1 and 2, which is formed by two triangles, right? And we know that a hexagon has 6 sides or 6 vertices, which means that now you have 2 times 6, which is 12 of the triangles which are formed by two triangles. Is that okay? And then we also have the triangles formed by all 3 triangles around the vertex, which of course, a hexagon has 6 vertices. So I have 6 triangles which are formed by 3 triangles altogether. Is that okay? And finally, don't forget that we can also do some big ones, which there are 2 of them, right? So we can say that we have 2 of equilateral or big equilateral triangles. Altogether, the total is going to be 12, adding 12, adding 6, adding 2, which goes to 32 triangles. Is that right? So that's for question 11. And now for question 12. It is like the chicken rabbit problems. A worker is delivering 200 vases. He gets $2 for delivering a vase safely and pays $10 if he breaks one. If the worker can make $280 after delivering all vases, how many vases did he break along the way? So 200 vases. Suppose that he is delivering all of them safely. That's going to be 200 times 2, which is $400, right? However, he's only making 280, which has a difference of $120. And by breaking each one vase, he's not only not getting the $2 for delivering it safely, but also paying an extra $10 for breaking one of them. Which means altogether, he is losing $12 from what he is supposed to get. So if the total is 120, we just need to divide 120 by 2 adding 10, which is 12. And that is going to be 10 of the vases broken. That's the number of vases broken. All right. So that's going to be 10 vases broken along the way. Is that okay? So that's for question number 12. Now, question number 13. Yuxin, Nicole, Waya, Allison, and Lewis are lining up to take a picture. If Nicole cannot stand in the middle, how many ways can they be arranged? So in this kind of questions, we always try to arrange the picky people first. If Nicole does not want to stand in the middle, it means that there's only going to be 4 other places that she can go to, right? Because Nicole is picky, so we satisfy her first, which is 4 different ways that we can arrange Nicole. And for the other people, they don't really mind how they're arranged, right? So for the remaining 4 places, we can just arrange them freely. The next one has 4 options. And then for 3 people left, there are 3 options, and then 2, and then 1. So that's going to be 4 times 4 times 3 times 2 times 1, which is going to be 96 different ways that they can be arranged. Is that right? And for wire, if wire must stand on either side, in how many ways can they be arranged? So now wire is the picky one, right? Which means that you just want to arrange wire first, which there are 2 different ways to arrange wire, either this side or that side, right? Either side. And then for the remaining people, they don't really care. So again, 4 times 3, 3 times 2 times 1. And that's going to be 48. So the answer is going to be 48. Okay? And that's for question number 13. For question number 14, there is dividing a large rectangle tile into small rectangles, 9 of them. The perimeter of the 3 rectangles in the first row and the 3 rectangles in the first column is 60, which means, say, A, B, C, D, E, F, G, H, I are all representing the perimeters, okay? So I have 2 times of A, adding B, C, D, and G equals to 60. Now, what we also know is that if you're thinking about B and D added up, by moving the side lengths, that is equal to the perimeter of this rectangle, right? Same goes for A and E. By moving the side lengths, that's going to have a total perimeter of this large rectangle. So it means that B adding D is A adding E, which means now I can say that B adding D is A adding E. And next, we can also see that for C adding E adding G, for the same reason, that's going to be the same as A adding E adding I. Because E is happening in both of them, so I can say that C adding G is the same as A adding I. So now we have 2A adding A adding E adding A adding I equals 60. And finally, for E adding I, you can see that's the same as F adding H, right? For the same reason. So it means that now I can just write E adding I as F adding H, which goes to 20. And 20 adding 4A is 60, which means 4A is 40, and that gives us A equals 10. So altogether, what is the perimeter of this large rectangle tile? We know that if I have A adding F adding H, by moving the sides around, that's going to be the same as the perimeter of this large tile, right? So it means that the perimeter is A adding F adding H, which is the same as 10 adding 20, and that's going to go to 30. Is that right? So for this question, the answer is 30. Not 36, 30. Hello, welcome back. So that's for question number 14. And then for question number 15, it is actually just a 1 second question. Because you can see that now, this is a magic square. Each row, column, and diagonal are equal, right? In a magic square, we can find a triangle model there, which the conclusion is 2 times of 8 is y adding 10. So 16 is y adding 10. And y is going to be 6, all right? So using the triangle model of a magic square, that's a 1 second question. Question number 16. Now we are trying to find the largest possible product of a 2-digit number formed by digits 2, 3, 4, and 5 without repetition. So if you want the largest product, of course, you want the higher places to be larger, right? So it goes to 5 and 4. And because we know that for the remaining 2 digits, they are 2 and 3, and no matter how you put them, the 2 numbers are going to add up to the same sum. So again, for the same sum, the smaller the difference, the larger the product, which means that you choose a smaller ones digit for the higher tens digit and a greater ones digit for the lower tens digit. So you have 52 times 43. That goes to 6, 15, 8, 20. So that's 2236 as the product. All right. And then the smallest product of the 2-digit numbers is going to be 2 and 3 to start with. And of course, a bigger difference means a smaller product, right? So for the smaller tens place, you choose the smaller ones place. The bigger tens place, you choose the bigger ones place. So now you have 120 and 720. So that adds up to 840. Finally, you just do 2236 subtracting 840. That's going to go to 6 and 9 and 13. All right, so 1396 as the answer. Is that right to everyone? That's the difference between the 2 products. As for question number 17, it is very much similar to the question that we have just been talking about. Do you still remember the rectangle one? But this time it's just using another application of it. So you just fill it up, basically. Now we are thinking about the areas, right? So it's no longer perimeters. For areas, we are just multiplying them together. So it means that these 2 rectangles multiplying together is going to be the same as these 2 rectangles multiplying together. Which means for the bottom right rectangle, we know that 5 times 2 gives this one as an area of 10, right? So for the top left rectangle, it goes to 12 times 15 divided by 10, which has an area of 18. So the question mark, you can see that this triangle is half the rectangle. 18 divided by 2. That's going to 9. All right. So this question mark is representing an area of 9 in this diagram. Is that okay? All right now. And for question 18, car X left place A at 8 a.m. Say this is A. This is X departing at 8 a.m. towards place B. At the same time, car Y is departing from place B, which is 8 a.m., and traveling towards A. So now, the distance between the 2 cars was 90 kilometers at both 11 a.m. and 3 p.m. So you can imagine that the first time at 11 a.m., when the cars are 90 kilometers apart, they still haven't met each other, right? And then the next time, when they're just trying to move on, and again, they are apart for 90 kilometers. That's like 3 p.m., right? So possibly I'm just going to do that, okay? Just for the easy understanding. Assuming that they are at the same speed, such that they're just swapping the positions. So now you can see that during these two times, the total distance traveled by the two cars is going to be 90 times 2, which is 180 kilometers. And the total time taken for the two cars is going to be 4 hours. So it means that the combined speed is going to be the distance, the total distance divided by the total time, which is 180 divided by 4, that's 45 kilometers per hour. So that's the combined speed of the two cars. And now, what is the distance between place A and place B? So the distance between A and B is going to be the combined speed of them, 45, multiplying the time that they have been traveling from 8 to 11, which is 3 hours. So in the first 3 hours, they must have combined in total, traveled 45 times 3 kilometers. And there's still a gap of 90 between them, right? So adding 90. And that's going to be the distance between A and B, which gives us 135 adding 90. That's going to be 225 kilometers. Is that okay? So that's the answer for question 80. You can think about it as a meeting problem. Now, question 19. We have a number puzzle right here. ADA adding BAB is DECD. So now, what we know is, if I have 2 of 3-digit numbers adding together, it will be 1,000 something if it goes to a 4-digit number. The thousands place can only be 1. So knowing that D is 1, we now know that because A and B added up must have a carryover, and A and B added up ends with a 1, so it means that A adding B is going to be 11. Is that right? But since I have already got D as 1, here in the hundreds place with A adding B, E cannot be 1 anymore, right? Because all the different letters stands for different digits. So it means that there must be a carryover here, and E has to be a 2. Now, in order to have a carryover, A has to be really big, right? In order to add 1 to have a carryover. And C has to be a 0 right there, because it cannot have 1 adding something going to 13, right? Even with a carryover of 1 right there. So if I have a carryover of 1, D is equal to 1, adding 8, that's going to be 10. So it means A is 8, B is 3. And that's how we can complete this number puzzle. Is that right? So it means that A is 8. For A, B, C, D, A is 8, B is 3, C is 0, D is 1. So the 4-digit number A, B, C, D is 8,301. Is that okay? Yes, 6 adding 5 is 11. But we need 1 adding A adding 1 equals 10. So that's the reason why I cannot flexibly choose what A is. A has to be 8. Okay? So question number 20. We have 6 3-digit numbers that can be formed using 3 different digits. Which means, actually I have, for example, ABC, ACB, BAC, BCA, CAB, and CBA, which each of ABC is representing a digit. Now you can see that as I have A occurring in the hundreds place 2 times, tens place 2 times, ones place 2 times, same goes for B and C. So the total of the 6 numbers should be 222 multiplying A adding B adding C. And that is equal to 3,194 adding one of the numbers, let's say that's ABC. That is remaining. So now you just need to see what adding 3,194 is a multiple of 222, and at the same time being able to fit the requirement of the equation. So now dividing 3,194 by 222. So that's going to go to a 1. 97 remaining, drop the 4. And that's going to go to a 4 with 888 there. 12 adding 74, that's 86. So with a remainder of 86, it means that at least you would need to add 222, take away 86, which is 136 to 3194. Is that right? However, if you're adding 136 to 3194, it means that it's 222 times 15, which 1 adding 3 adding 6 is not equal to 15. So it means 136 is not a solution. The next multiple is going to be 136 adding 222, right? So probably I shouldn't write it there, or maybe I should use another color. So if you're stacking another 222 on, that's going to go to 358, which is going to be 222 multiplying 16 when you're having that adding 3194. 3 adding 5 adding 8 is 16 indeed. So it means that that is going to be the answer, all right? Which means the remaining number is 358. Yes, that's right. We are dividing 222 on both sides. And to see which number adding that is going to be a multiple of 222 that fits the equation with ABC. All right? So that's what we have. And then if you keep trying to add some 222s, you can see that the later two are impossible as well. So that's the answer for this question. All right. And for question number 21, basically you just need to know that whenever you have 2 square numbers, a squared take away b squared is a plus b multiplying a take away b. So that's like the difference of 2 squares formula. So 60 take away 59 can be written as 60 adding 59 times 60 take away 59, which is 1. So you can see that the next one is going to be 58 adding 57 times 58 take away 57, which is also going to be 1, right? So on. So you can see that this equation is actually equal to 60 adding 59, adding 58, adding 57, all the way to 2 and 1. Which is, yes, like a Gaussian sum or like an arithmetic sequence, right? So 60 adding 1 times 60 divided by 2. which is 61 times 30, and that is going to be 1,830. Okay? So this is going to be the answer for question number 21. Question number 22. 2016 mice lined up in order around a circle, and a cat eats them according to a pattern which is starting with a randomly chosen mice, eat it, and skip one, eat another one, skip one, eat another one, until there's only one mouse left. So if the last one alive is 2008 mouse, what is the cat starting to eat from? So what we know is that if I have the number as a power of 2, the total number of mice as a power of 2, then the first round is going to cancel out all the multiples of 2 if you're starting from, say, the second one, right? So the first one is safe, of course. And the second round is going to eliminate, because now it becomes 1, 2, 3, 4 for the new order, right? So the second round is again going to eliminate everything like that. And the third round, because it becomes 1 and 2 now, so it's going to be eliminating that. Which means what we have is that before the first one to take away, like the number 1 mouse, is always going to be safe, right? Which means that the first mouse before the power of 2 starts is going to be safe. But now we know 2016 is not a power of 2, right? Which means I want to simplify this case such that the total number of mouse is going to be a number of 2 first. And the biggest number, which is less than, biggest power of 2, less than 2016, is going to be 1024. Yeah? Which is 2 to the power 10. And that's less than 2016. The next one is going to be 2048 already. So that's too big, right? So now it means that you need to reduce (2016) take away 1024. That is going to be 992 mice before it becomes a power of 2. So now let's say I'm starting from 1, 2, 3, all the way to 2016. And let's say the first mouse I'm removing is the first one. So after 992 mice are removed, it means that altogether, the last mouse to be removed, if you're thinking about 992 odd numbers, that's going to be 1 adding 991 times 2, which is going to be 1983rd mouse as the last one eliminated before power of 2. So it means that now with 1024 mouse left, whoever is the 1984th mouse is going to be safe to the very end. But that is based on the assumption that the first mouse taken away is the number 1 mouse, right? So if now we say is that the one alive is the 2008 mouse, actually, which is in order 24 more than our assumption. It means that the first mouse taken away will also be 24 more, right? In the actual case, which is the 25th mouse. All right. So it means that the cat is starting to eat from the 25th mouse. So that's for question 22. And then for question 23, 16 people participating in a knowledge quiz test, and they're divided into 4 groups. Within each group, single round robin tournament rules will be used, which means that every two persons are going to have one game between them. So it means that within each group, there's going to be 4 people, right? And every one of them will be playing against the 3 other players. However, we know that if I have you playing with me, that's the same as me playing with you, right? So every game is actually counted 2 times. Like there's a duplicate count right there, which we need to divide it by 2 because there are 2 participants. So we have been counting it twice for every game. And that's going to be 6 games played in each group, which there are 4 groups. So at the group stage, we need to play 6 times 4, which is 24 games. Is that right? And now, after the group stage, each group has 2 winners, and they're going to the knockout stage, right? So we can just simply think about it. Between every 2 of them, which there are 8, because there are 4 groups, there will be 1 winner. So that's 4 games, right? And between every one of these winners, it will perform 2 more winners and 2 more losers. However, the question also says that they need to determine the winner, runner-up, 3rd place, and 4th place. So apart from the final, which determines the champion, you would also need another match between the 2 losers of the semi-finals to determine the 3rd place and the 4th place. So that's going to be 4 games, 2 games, and 2 games, altogether 8 games for the knockout stage. So the total number of games is going to be 24 adding 8. That is 32 games. Is that right? So that's for question number 23. As for question number 24, it's a question related to average. So in a test, the average score of boys is higher than the overall average by 2 points, while the average score of girls is lower than the overall average by 1 point. So say this is the overall average. If I have this as the number of boys, and this is 2, this is the average. Now it means that the total number of scores more than the average by the boys is going to be 2b, right? And let's say this is the number of girls, which each of them is going to be 1 less point than the average. It means that the total shortage to the average is going to be G. And we know that whatever is above the average should be whatever is the same, should be the same as whatever is below the average. So it means that we know the number of girls is the same as 2 times the number of boys. Is that making sense? So now if I know that, it means that when, suppose I have the same number of boys and girls. It means that the total score of the girls is going to be 1,800 divided by 2, which is going to be 900, right? Because now we only have half the girls left if the boys are the same as girls. And the total score of the boys is 942. So we know each boy is going to be 2 points above average. Each girl is 1 point below average. So that's going to be 3 points difference between a number of between each boy and each girl, right? And altogether, the difference is going to be 942 take away 900. That's divided by 3 points between every boy and every girl. Or, of course, if you don't like to use fraction, just use a division sign, dividing 3 points, and that's going to be 14. 42 divided by 3, right? 14. So that's the number of boys. Because now we are making the girls only having half of them, right? So it means that the number of girls is going to be 2 times of that, which is 28. Is that okay? Well, I'm slightly overrunning, but since we have just got the last question, I will still cover it, all right? Such that we have a happy ending today. So, the last question. Jenny and Yamamoto each have some candies. And at the beginning, Jenny has fewer candies than Yamamoto. In each operation, the person with more candies gives some candies to the person with fewer candies, so that the number of candies of the one that receiving is doubled. After 2017 times, Jenny had 10 candies and Yamamoto has 8 candies. What is the original number of candies each one of them have? So we know that for this kind of questions, if it is going 2017 times, then it means that there's got to be a pattern in there, right? So we just need to find the pattern by doing more times of this operation. And then we can picture how this operation is done previously. So starting from Jenny and Yamamoto for the 2017th time, having 10 candies and 8 candies. So it means that next time I'm going to double up Yamamoto to 16, and that's going to be 2. And then Yamamoto is going to double up Jenny. That's 4, and that's 14. Doubling up Jenny again. That's 8, and that's 10. Oh, so basically that's how it works. It's going to go repeating. I'm just going to write it smaller. 2, 16, 4, 8, 4, 14, 8, and 10. And then it goes to 16, 2, 14, 4, 10, and 8, which means that every 6 times is a repetition, right? So starting from 2017 time, it means that there's still going to be 2016 times before that, which is going to be how many repetitions? Divided by 6, that's 336 repetitions. Exactly. So it means that the first time, after the first time, it's still going to be 10 and 8. So before the first time, what's going to happen? Is that just tracing back to 14 and 4? Not really, because it says that Jenny has fewer candies than Yamamoto, right? So it means that the first time, Yamamoto is providing to Jenny such that Jenny doubles up to become 10. So before doubling up, Jenny is 5, Yamamoto, 13. So that's the original number of candies. The original of Jenny is 5. The original of Yamamoto is 13. Is that okay? So that is going to be all the questions in the sample paper last year. All right. So I hope you all enjoyed, and I will see you at the same time next week. I will be sending out this paper for last year, like the real paper for last year, tomorrow. So just stay tuned in the chat, and I will see you all next week. All right. Have a good evening. Bye-bye.